Um, Hello, welcome to today's campus department update with Dr. Travis Kowalski, the interim department head of the mathematics department. My name is Sarah Von Eye, and I'm the interim alumni director here at CARA. And just some housekeeping tools before we get started. The event will be recorded and will be uploaded to our YouTube channel. So if you would like to see it for future reference, we'll have it there. If you can, there's a chat function. So switch it to all panelists and all attendees. We'd like to know who's here. So just put your major in your class just to say hi. And then we'll have a question and answer period towards the end. So if you have any questions, just drop them in the Q&A box and we'll read them out loud so everyone can hear the question. So without further ado, please welcome Dr. Travis Kowalski. Oh, you're muted.
Yeah, my screen suddenly let me know that I'm talking into the void. So thank you everybody for being here today. I've got some PowerPoints that I will share with the group. So let me do that. And so I hope everybody's seeing a big blue overview of the campus. Are we getting that from everyone?
Yep, looks good.
Thank you, Dane. All righty. So what I wanted to do today was to give you kind of an update on what's been happening in the department, what the department kind of looks like, who the faculty, who our students are, what kinds of career opportunities and paths our students are taking, what are some of the new kind of developments. And so I'm really going to kind of try to focus this on sort of four big areas, and then have some time afterwards for questions and answers to fill in things that you might want more information on. And so I'm going to talk a little bit about the McLaury Building itself, which just completed a renovation, talk about what it is that our faculty are doing in terms of teaching and research, talk a little bit about the curriculum, how it's been updated over the past couple of years, and talk a little bit about the students and what it is that they're doing. But before I hit any of those things, I'm going to be kind of upfront here and just sort of tell you straight up, it's been a rough couple of semesters for the campus as a whole, but for the department in particular. So let me just kind of give you a rundown of the past 5 semesters in the department so you have an idea of the framework that we're working from. In spring 2019, computer science, which was a part of the mathematics department, split from math and joined computer engineering to form a supercomputer department. This was sort of announced to computer science and to math and to computer engineering and electrical engineering about 2 months before the actual split occurred. So spring 2019 was a very transitional period. I was installed as the interim head for the math department. Jeff McGew became the head of the computer science and engineering department. And so that semester was spent trying to disentangle 2 departments that had been together since the 60s into 2 sort of standalone programs and to figure out how to make that function. That was followed in fall 2019 by the final phase of a 3-year, 3-phase renovation of the McLaury Building, right, our ancestral mathematical home. That final phase involved floors 2 and 3, which meant that it displaced all mathematics faculty and all math courses from the building. So our classes were scattered across the campus. The faculty themselves took up temporary residence as refugees in the classroom building, in basements of some of the campus buildings. A number of us went across the street to the old foundation building, what used to be the Western Dakota typewriter store. And so not only was the department sort of trying to figure out how to get itself untangled from computer science, but now we were physically disconnected from each other. Then we'll add to that spring 2020, which was the plague. So the plague made it impossible for us to ever get together. It caused a public shutdown of the campus, and it forced a complete transition of all of our classes to online education abruptly during mid-semester. Students left for spring break. got an announcement that they were going to get a second week of spring break, and then came back to, well, never came back actually, just had online courses. That was followed with this past academic year, where we have been adjusting as a campus, as a country, to the ongoing pandemic. And so classes in the department and across all the programs were a mix of in-person classes, online courses that were fully handled in the digital domain, and hybrid courses that involved rotating a cohort of students who were in class while other parts of the class were either watching online or doing exterior activities. At the campus itself was under a mask mandate. We were socially distanced in all of our classrooms. And so it just meant for a very quiet campus, because on any given day, only about a third of the students were actually ever on the campus. And so it's been kind of a strange couple of semesters that the department's been working its way through. Well, you know what they say, when the universe gives you lemons, well, if you're a mathematician, you probably prove the existence of lemonade. And so I'd like to go and look at this as there being a lot of new opportunities that have unfolded over the past several semesters. So one of them is the McLaury Building got renovated. Our 100-year-old ancestral home has been transformed into a 21st century learning space. And so I'll take you through a kind of a virtual walkthrough of the building in just a second. There's been a number of department successes. This has been a really challenging time. And so faculty have really stepped up. They've developed a number of new online courses. We've renovated a little bit how we think about some of our remedial math classes. We've still continued to do research. We've managed to hire 3 new people over the past 2 academic years. And so the department's kind of growing and moving its way forward. We redesigned the major. Since we could no longer kind of depend on the synergy of math and computer science, we revamped the mathematics major to be more flexible, more streamlined, and to allow greater connections with the other programs on campus. And we've started a student success initiative, not just for mathematics majors, but for all hard rockers, with a revamped intro sequencing and the introduction of a brand new math help center. And so these are the 4 things that I'd really like to talk about a little bit. So let me start off with the virtual tour of the new building. This was a 3-phase renovation I'd mentioned. It was completed in August 2020, and my hats go off to all of the folks over in the campus facilities who were somehow able to get the building on time, under budget, in the middle of a pandemic. So the first phase of the building essentially put in a new elevator and changed out all of the windows. And then the other 2 phases have been a major restoration and renovation. So the only things about the building that have sort of stayed the same are the exterior and the marble staircases, sort of 2 kind of fundamental features of that. It's stately pillared exterior and those pair of marble staircases with a century's worth of student treads worn into those. But everything else on the inside has kind of been revamped and spruced up a little bit. So let me sort of show you what the new kind of gleaming interior looks like. It's white and shiny space. The image on the far right shows the hallway that leads to the joint math and computer science and engineering joint department offices. The middle picture on the top is actually the front office, where the staff for both math and computer science and engineering works together. So we're separate departments, but we're still we're keeping our familiar relationships with each other. Beneath that, you can see a picture of one of the new renovated classrooms. So kind of the old stately slates are gone. And that was a hard thing for the faculty to let go. But the new classrooms are really, really nice. They have a number of features that are designed to make this a much better, more active learning space. For example, all of the classrooms on all 3 of their main sides have high quality glass board that allow students to do work. There are these Hudley cameras that have been installed in all the classrooms that allow instructors in the classrooms to be able to talk to both the students who are in there, but also students who are telecommuting to class, who are watching on Zoom or in some other platform. And so it's turned all of our classrooms in the McLaury Building into virtual learning spaces as well as practical learning spaces. We have a number of routers and power points in the buildings to allow students to be able to go and work with their laptops and other technology as needed for their courses. And in many of the classrooms, they have a projector system with a screen that recesses into the ceiling, or if that's not high tech enough for some of our faculty members, half of our classrooms, instead of having a drop-down projector, actually have a smart monitor in there, which allows the faculty to interact with the screen dynamically and have students able to share their work back and forth. And so we've got just a number of different ways for instructors to kind of engage with their students, engage with technology in kind of new and meaningful ways. It's not just all classrooms and hallways, though. I want to show you some of the other interesting spaces here. There's a student study on the 3rd floor. In the before times, before the plague, this was a really happening place for students. Math majors would gather in here. They'd be working on problem sets on the sides. They'd be it was a good place for fellowshipping. It's also a great place for math faculty just to kind of come in and get to chit chat and know our students. It's one of the best things about this department is kind of how familiar everybody is with each other. And so this is sort of a dedicated space just for the math majors. There's also a really nice new teleconference room here in the main office. It's got an 85-inch smart monitor that allows us to be able to go and have conferences with folks virtually using Zoom to be able to go and interact with people on campus when we couldn't meet in person. And so it's been a really useful tool for us to go and have. On the 3rd floor, we have a large computer science and computer engineering research lab, the Opp lab, named after Roger Opp. Also, the 1st floor has been turned entirely into active student spaces. So this is one of the rooms down on the 1st floor, the 3D print shop and the robotics lab. And so you might have remembered that the 3rd floor or the 1st floor of McLaury, the sub-basement floor, had sort of become kind of a catch-all for whatever the university couldn't find a place for. And it's actually been turned into a really nice dynamic student space down there. I have 2 more shots of the interior of the McLaury Building, just to kind of point out that right now, this building is sort of a blank slate. We haven't put up any of the old artwork. So a lot of the old posters that had kind of weathered away haven't gone up. The grand portrait of McLaury hasn't yet been hung. And the reason why is we want to turn this space not just into a learning facility, but also an advertisement for what it is that mathematics can do, what it is that our students are doing, what it is that our alumni are going and doing. And so the grand vision that I have for the 3rd floor, where most of the math offices are, is to have various posters put up along the hallway and in the main stairwells that would advertise student research projects, that would advertise what it is that alumni are going and doing. So employment opportunities and job descriptions, so that students who are not just math majors, but are here in the building waiting for their math classes, have some idea of the kinds of employment opportunities that are out there. In the main stairwell, it's an opportunity to maybe put up some new artwork, or to maybe rotate that artwork every few years so that we can have some nice interaction with the local community as well, being able to add a little bit of beauty inside our brand new building. So that's kind of a quick walkthrough of the new McLaury Building. Of course, a great building by itself isn't going to give students the instruction they need. You also have to have great faculty, and our faculty is spectacular. We currently have 17 full-time faculty members and a full-time program assistant that helps with our teaching. And so I just kind of like to let you meet the new folks. These are the people, and I'm going to give you kind of just sort of a quick introduction to the people who form the Department of Mathematics. We have 4 full professors. Dr. Brayman comes from the University of Kansas. She's been here since about 2004. She's an expert in numerical linear algebra and multilinear algebra. Roger Johnson is got his PhD from the University of Minnesota. He is one of our resident statisticians, an expert in statistics, decision theory, parameter estimation. He very often teaches our upper level statistics courses and design of experiments classes. There's me, Travis Kowalski. I am a professor in the department and currently the interim head of the program. I'm a specialist in complex analysis. I'm in formal power series, so I tend to teach an awful lot of advanced calculus and complex analysis courses. I'm also interested in the scholarship of teaching and learning. Dr. Don Tietz is the elder statesman of the department. He is an expert in astronomy and celestial mechanics. He is a wide-ranging instructor who likes to teach everything from the calculus courses all the way up to the advanced calculus courses and everything in between. I'm going to toot a couple of folks' horns here. It's weird to go and toot my own horn, but I got to sell what it is that we go and do here. I was awarded the 2020 Burton Jones Award for Distinguished Teaching by the Mathematical Association of America, and I also won the 2020 Chauvenet Prize for a paper I wrote called The Sign of a Single Degree. This year, Dr. Tietz was also recognized. His paper, the Gauss's estimate of the Easter date, was selected for the 2020 edition of the Best Writing on Mathematics from Princeton University Press. So those are two nice shout outs for some of the expository paper that our faculty have produced in the recent years. We've got 4 associate professors, Dr. Cottle, Garlick, Clicky, and Riley. Dr. Cottle is our other main statistician. He focuses on massive data streams, big statistical problems, and time series forecasting. Dr. Garlick is our resident expert in mathematical biology and ecology. She is sort of key in our math modeling courses. Donna Clicky is a part of the atmospheric and environmental sciences program, but is housed here in the math department. So on the math side of things, she teaches some of our introductory math courses, along with focusing on some of the upper level atmospheric and environmental science courses. And Dr. Riley was my predecessor. He was the former head of the department. He's an expert in numerical linear algebra and mathematical modeling. He's also got a lot of bona fides in program assessment. And so he's helping to kind of guide the mathematics program as we move forward. I'm going to go and give another shout out to this group right here. These are our department's sort of funded research experts. A lot of you might know that it's kind of hard to pull big ticket funded research on the pure mathematics side of things. And it's actually a challenge to pull even reasonable dollar amounts on just applied mathematics. But these 3 do a very great job on that. They generate between $60,000 to $80,000 in expenditures each year. Dr. Kyle is currently working on what might be a $1.1 million grant with the Naval Surface Warfare Center, a large data analysis project together with CSE. And so these folks right here, Dr. Cottle is sort of a specialist in big data and machine learning, who has a lot of funding from the Naval Surface Warfare Center and the United States Department of Defense. Dr. Garlick does an awful lot of mathematical biological modeling, in particular modeling prion dispersal in ecological systems. So if you've heard of chronic wasting disease or the zombie deer disease, she has a significant amount of NSF funding to help with modeling, prediction, and mitigation of the spread of chronic wasting disease. Dr. Clicky, in addition to bringing in a lot of funded research on the AES side of things, is kind of a department specialist in STEM education. And so she, along with Dr. Garlick, have been putting together a number of what are called computational astronomy grants through a NASA EPSCoR program. And so these are kind of our main funded research folks. I'm going to give one more shout out to Dr. Cottle. In addition to teaching a bunch of classes and bringing in a bunch of money, he's also kind of the department's go-to coach for our data analysis teams. We actually field teams for 2 different data analysis contests every year. And under his coaching, they've done really, really well. In fall 2019, we had a team who placed 3rd place in the novice division, novice meaning that was their first time there. Also in fall 2019, we had a team who placed 1st in the undergraduate division. That means that that was their 2nd time showing up, and they placed 1st for the undergraduate teams. In spring 2020, another student that he coached, Shashwati Shragra, took 2nd place for her paper at the undergraduate statistics project competition. And so we've been doing good generating some competitive mathematics along with teaching our mathematics. Continuing on with the folks that we've got here, we've got 3 assistant professors. Drs. Deshaw and Fleming have been here for a while. They're experts in combinatorial matrix theory and graph theory and geometry and non-associative algebras, respectively. Dr. Steinberg, Neil Steinberg, is actually a brand new recruit. Last year was his first year on campus. He is an expert in commutative algebra and on torsion and module tensor theory. In addition to our professoriate, we've got a number of lecturers. Peter Grieve comes to us as an alum from the School of Mines with a bachelor's work from Caltech. He specializes in teaching a number of calculus courses with an aerospace flavor. He's an extremely popular instructor for those. Dr. Erin Hamburg earned her degree from the School of Mines. She actually has multiple degrees in mathematics, in physics, and in nanoscience. She teaches a broad range of subject in the department and also a broad range of modalities, in-class, hybrid, online, depending on what's kind of needed for any given semester. Tristan Lehman is a former hard rocker herself. She's one of our innovative pedagogy specialists in assessment and delivery. Matt Leonard is a lecturer from the University of Wyoming. He's one of our 300 level specialists. So he teaches a number of courses in differential equations, in probability and statistics, using a number of kind of innovative assessment measures to get students to sort of focus on those toolkits. Michelle Richard Greer is kind of our online D2L guru. She teaches a wide range of classes, but she was sort of instrumental in helping our program adjust from the before times to the post-plague online universe. And Jeff Winter is a brand new instructor. He's coming to us from Black Hills State as our math center coordinator. And I'll talk about the math center in just a little bit. And then Rita Davies is our program assistant. She's the glue that holds the department together. Without her, we don't buy, we don't get our textbooks, we don't hire our students to help out. So probably out of all of us, the most important person in the group. So that's kind of a quick look at the faculty side of the department, but let's also talk a little bit about our students here. Right now, we've got 41 math majors. We'd like to get that number up to 60, and I'll explain why in just a second. We do pretty good on our gender balance. About 40% of our students are women. The national average in a math program is closer to 25%, so we're doing pretty good up there. About half of our majors are actually double majors. Mathematics is the single most popular 2nd major on campus, with math and computer science being the most popular pair of all. Our students have become very active in a number of mathematics competitions. And so every year we field teams who compete in 4 major contests. The MUDAC data analysis contest in spring, the mini analytics data analysis contest in fall, the COMAP modeling contest in spring, and the Putnam exam in fall. And so the pictures I've shown here are actually teams who were competing in both of those. One of those is a team from mini analytics. The picture on the bottom is a team from the COMAP contest. So every year we graduate about 6 math majors, and I'd like to get that number up to 10. That's where that 60 in the previous slide comes from. 6 math majors means we make up about 3% of every graduating class. And for many years, if you were to look at the degree backgrounds for people who are working in STEM-related fields, 3 to 4% of those were people who had math majors. So we're kind of right at what the market will bear. I'd like to get that up to 10. In other words, I'd like to be closer to 5% of the campus's graduating class, just because it would give us a little bit more robustness in the kind of courses we'd offer, because we'd have a larger program without sort of inundating the market with too many mathematicians. Now, about a quarter of our graduates will go off into graduate school. They have a 100% acceptance rate in getting into graduate schools. A number of them have gone on to become faculty at other institutions. We have faculty at Gonzaga, faculty here at School of Mines, faculty at Purdue. The rest of our students will head off into industry. Our graduates right now enjoy a 93% job placement rate with an average starting salary of about $56,000. The kinds of careers that our graduates going into are largely based off of versions of data analysis and visualization. So either classical data analysis, statistical analysis and prediction, actuarial or financial analysis, or applying those tools to another discipline like software development and testing, defense and energy management, telecom, aerospace, space exploration, pharmaceutical drug trials, and manufacturing testing and process are some of the most common types of careers that our majors will go into. And I've included a number of companies that students have gone to in the past several years. The upshot is that these kinds of careers are what 21st century business needs. Every year, U.S. News and World Reports puts out their list of sort of the best jobs. And for the 2021 list, which was just recently released, statistician, data scientist, actuary, and mathematician round out the top 50 of those. Mathematician took a hit this year. We were number, I think, 9 in 2019. And then when the plague came, none of these math positions, I think, even broke the top 30. They were all medical and pharmaceutical companies, or pharmaceutical positions. So we've kind of bounced back a little bit there. So if we're trying to get students into these good careers, and we're doing a pretty good job about it, how are we doing that? Well, we're always trying to make sure that the curriculum is appropriate for the kinds of jobs and the kinds of work that students would like to be able to go and do. And so when the department split, we decided to go and take a look at the curriculum, and we made some renovations in it that allow majors to customize their coursework to match their career interests a little bit easier. It makes it easier for students to earn double or dual majors, and it sort of streamlines the core courses while expanding the electives. And so I'm going to walk you guys through it so that you can kind of see what it is that we're doing here. There is a mathematical core, which is going to look pretty standard. There's the calculus series, differential equations, linear algebra, probability and statistics, abstract algebra, and advanced calculus. Pardon me, sort of form the traditional mathematical core. We've made some adjustments here to put some more emphasis on linear algebra. A lot of students who have gone into industry have sort of emphasized that more linear algebra skills sort of peppered through the program would be useful. Matrix theory, vector theory, singularity theory, things like that. And so in our Calculus 2 courses, we've actually added a section of what you might think of as sort of review preview of vector and matrix theory that is designed to make calculus blend much more easily with some of the vector and matrix ideas that will pop up in Calculus 3 and differential equations. We've also added a second follow-up to linear algebra, an advanced linear algebra course, which we will be teaching for the first time next spring, which handles higher order matrix decompositions, singular value decompositions, some numerical linear algebra ideas, things that would tie well to 21st century applications. We've also moved some of the coursework around so that we can offer a lot more electives on the student side. So we have a collection right now of common electives that are in sort of a frequent rotation: complex analysis, data analysis, partial differential equations, mathematical modeling, and then a topics course, which varies from instructor to instructor and semester to semester. We also have a collection of 300 and 400 level classes in other programs that have non-trivial math content that's designed to help the transition for students who are interested in double majoring. We've kept the core computational courses. We have a year of programming along with our finite structures course, which is sort of a computer science oriented version of a discrete mathematics class, and introduction to numerical analysis is part of our core curriculum to train applied mathematicians. There's all of the usual boilerplate that I'm not going to sort of focus your attention on right here. I just wanted to circle this thing at the bottom. We tried to go in a different direction than a lot of the other programs on campus and open up some of the free electives. And the idea here is that students work with their advisor from their first semester here to find the mathematical or engineering courses that will make them more hireable based off of what it is that they'd like to go and do. So for example, if they want to stay in-house, we're developing a data analysis track and an actuarial sciences track starting in spring 2020 that would give some direction to these free electives. If students have an interest in some related discipline that they would like to apply their mathematics to, they could get a minor in one or two of those disciplines using these 36 credits to kind of hone their skill set. One of the issues that's a challenge for our major is that while we have two career fairs every year, and we get 120 to 140 companies there each time, very few of those companies actually advertise and are looking for math majors. The Navy and the Army are kind of the only two who ever do. And so if we want our students to be able to kind of talk to some of these recruiters for some of their jobs, being able to have a track or a minor opens the door to that discussion. If they hear, I'm a math major, half of the recruiters will think you're a bookkeeper or you're a teacher. But if you can say, I'm a math major with a minor in this, with an emphasis in this, with a track on this that shows up on your transcript, that opens the door to talking to a lot of these recruiters because they at least now know you talk the same language. And so that's been an effective tool for getting students employed. It also allows, it makes it much easier for students to double major. In the prior to 2019, if you knew you wanted to double major with math and something else when you came to the campus, you could make that work really easily in 4 years. Not easily, it's a math degree, nothing's easy for us. But you could make that work with planning and be out in 4 years. But if you were a student who came into math as your double major from another discipline, you were taking your other courses, took a number of your upper level classes and then said, I like this stuff, I'd like to learn more about mathematics. It was very hard to add the necessary math classes to your current program without adding a year or sometimes two to your graduation plans. And a lot of students maybe would accept adding an extra year, but if it was going to take 6 years to get your 2 degrees, that turned away a lot of students. So we wanted to make sure that we could build a gap in the program for double majors that would allow them to connect their other major to mathematics in an organic way, that they could get the classes that were needed for their degree on the math side, but also that would make them hireable with their other skill set. And so that's what we put together here. The last part of the curriculum that's my favorite part of the curriculum is the undergraduate research sequence. You might remember a long time ago that this was really a 1 credit course, or it was 1 semester class. And we've expanded that into an entire year. So the first semester is the emphasis on the research part, learning to read the literature, learning how to take your problem and chop it down into small pieces, learning how to make headway on those. And the second semester has been focused on the communications aspect. How do you take that and turn it into a technical paper? How do you take that and turn it into a presentation for a specific audience? How do you take that and turn that into a poster session? And so this 1 year sequence better models the capstone experiences in other programs. It allows double majors to tie their 2 capstone experiences together a little bit better. And it's actually just resulted in some really nice projects. because students have a time to get really invested in that undergraduate research. And that's really what we're talking about here. So I just wanted to show a couple of examples of student work from projects over the past couple of years. The upper left-hand corner has a project that a student did on something called scoregami, which is a paper folding and cutting problem. This is what's known as the mountain fold scoregami problem. And this result right here, which was actually proven over the course of 2 different students' work, one who built the model and one who expounded on the model, represents what is the best known result in this particular branch of mathematics when it came out, according to the mathematicians who proved the fold and cut theorem, which is sort of the pinnacle of this idea. The image in the middle on the right, what looks like the orbital elements, that's what the picture is, came from a project that was actually partially funded by a NASA grant to help do some work on Lagrange points for the James Webb Telescope. So our majors are getting a chance to be kind of right at the cutting edge relatively quickly in their careers. So that's one of the things that I'm kind of most proud of in our program, is that ability to give our undergraduates that exposure very early on. So we're not just our majors though, we serve the entire campus. 1 out of every 6 credits on this campus is a math credit being taught for all of our hard rockers. Almost everybody's going to have to go through a college algebra, trigonometry, calc 1, 2, 3, differential equations, and or probability and statistics. And so success in these math classes is what success is here at the School of Mines. And so we're trying to improve that for everybody on campus. And so we're starting to implement a 2-stage plan to improve that. So the first prong of this plan is a revamping of the intro sequence. Right now it's either college algebra 2 trig 2 calculus. And so we're getting rid of college algebra and replacing it with what amounts to a boot camp, a 5-credit course that will build the necessary algebra and trigonometry skills, while also building active learning strategies to help students transition from high school into college math, the speed and the rigor that goes along with that. It's also a unique course here that's designed to kind of destigmatize what we would call remedial math coursework here. A lot of times students who are placed into college algebra or trig are very resentful of that. And that resentment tends to result in students who are kind of just unhappy with the course even before it starts. And so we're trying to essentially give this the idea that we're going to go and get students Calc 1 ready by the end of that first semester. We wanted to implement this last year, but the plague came. So fall 2021 is going to be our first implementation of this engineering pre-calculus sequence. Tied to that is the Math Help Center. So they're currently remodeling the Deborah Library, and on the 2nd floor, it's going to be turned into a large student space. So there'll be a maker space there, but there's also going to be a chunk set aside for a Math Help Center. And so the idea of this is going to be tied to the intro-level math classes. So right now, Math 116 is going to be tied to this, where students actually have to serve time in the Math Help Center to learn how to budget time for homework. The Help Center itself is going to be staffed by both math faculty and math students. And so it's going to give these students a chance to meet the other faculty, to meet other students, to get over the hump of talking to faculty, or getting over the hump of asking for help. Our goal is to kind of change the paradigm of our incoming students so that they know where to get help, that they know how to get help, and that they can get connected to student success. So as I mentioned, this is being put together in the library. This is what the library looks like right now. The renovation is going to give it a lot more window space, a lot more open vibe to it. The Math Center is going to be over here on the southeastern corner, that purple trapezoid down there. Our basic idea is that this is going to be sort of a modular space that's going to be divided into 4 zones, roughly speaking, pre-calculus, trigonometry, calc 1, and calc 2. And then there are 4 pods in the back where students can form study groups or work on individual tests, things like that. Here's a basic, or here's an artist rendition of what the space is going to kind of look like. It's going to have a lot more rolling whiteboards and rolling chairs in it though, so that students can move and rearrange themselves. It's called the Mathematics Assistance Center, the Mathematics Help Center, but it sort of colloquially has picked up the name the slide rule. And so I don't know if you can see it behind me, but some of the old 1960s era teaching slide rules are going to find a new home in this place. This kind of interface between the old and the new. We have a new faculty member, Professor Winter, who we just brought on to help manage the facility. And like I mentioned, it's going to be integrated with our 100 level math courses to kind of ensure that all students learn kind of how to learn as they work their way through their School of Mines experience. I guess there's one last thing I'll sort of mention here is the West River Math Contest. This is the premier regional mathematics contest for middle and high schoolers. It's in its 70th year now. And we're up to about 450 to 460 of some of the brightest, most motivated students across what's now a tri-state region. We have students who come from South Dakota, from North Dakota, and from Nebraska to visit the campus, to be celebrated for being a nerd, for being good at math, and to take these tests to kind of hone their skill set. It's one of the kind of highlights of the year. It's a great chance for students to come to quote the smart school, to be kind of honored for that one. It's also a great recruitment and advertising tool. Every year, the students who win, they usually have little spreads in their home papers. Some schools actually keep track of their tallies, how many years they took the high place in the West River Math Contest. And so we'd like to be able to turn this into a good recruiting tool so that we can identify students who would fit well with us and start building a relationship with them early on, the minute they show up at our first contest. We were unable to hold them though in 2020 and 2021 due to the pandemic. So we're planning on a big one in 2022 where we're going to debut the Julie Dahl Award, the overall winning award, in honor of Professor Dahl, who many of you might remember. She retired at the end of 2019 after 30 plus years of service to the school. And so that's kind of an overview of what it is that we're doing right here. It's a great time to get involved. It's just an exciting time. We have this new building. We have a new major. We have a new math center that's on the way. There's lots of ways for you to be involved in helping to shape and improve the mathematics program as we move forward. If you're interested in being a part of an industrial advisory board to help us build electives to better serve industry needs, I would hope that you would become a part of that one. If you've got things that you'd like to contribute to my poster wall on the 3rd floor to help get students interested in what it is that you do, what it is that you think is cool about mathematics, let me know about those things. If you've got a company who would like to go and help sponsor a little bit for the West River Math Contest, we give you a shout out during the ceremony. If you've got, if you happen to know an artist who would like to go and dedicate some artwork into our big stairwells to kind of beautify our brand new building, there's a lot of chances to go and do that, depending on how much time and energy you're willing to go and expend. So if you are interested in those things, I've included my contact information here. You can send me an email, you can give me a call, and I will be happy to let you know what we need and to work with you any which way we can. So the only other thing that I had wanted to do is just sort of put a memoriam up here. I don't know, many of you probably took classes with Dr. Roger Opp, who passed away last April. And so we've found his plaque that we're going to go and put up on the Opp lab up on our 3rd floor. It was kind of a bittersweet moment to know we're not going to go and have shouting Roger to be able to open that up for everybody. So the best compliment I ever got was someone wrote on a teaching evaluation that I was Opp the younger. And so I keep that one with me with pride. So with that, I will turn the time over to the folks. So is there any questions that I can ask? I guess I should stop the share. Are there questions that I can answer? Are there things that are in the chats? I will turn it over to the people who can see who can see that stuff.
Yes, if you have any questions, so thank you, Travis, for your presentation. If you have any questions or comments, please put them in the Q&A or the chat and we'll look for them. And I didn't know if you saw the attendees, Travis, but Julie Dahl is actually on the so we'll give it a
Thank you, Jolie, for everything you've ever done for us. We
yeah.
miss you.
And while we're waiting for questions, and I'm gonna drop a survey here for feedback. So if you have any feedback, we greatly appreciate it. Or if there's any topics or anything you'd like to hear in the future, please provide us, or we appreciate the feedback. And then while we're waiting, just a shameless plug, Reunion 2021 is coming up. And I know my dates are off here on my virtual background. The schedule has added more events, the schedule has had more events added to it. So please check that out. I'll drop the link. Also, the departments are going to be doing department tours. We'll have tunnel activities. We'll have lunches, breakfast. It'll just be a lot going on. It's $10 a person. If you're going to do the golf classic, it's $125. So we encourage you to attend. So please come. And that $10 does include the Saturday night banquet that everyone is invited to. So we appreciate that. And then one other event, and I dropped all this information in the chat, so you'll see your chat box light up. Dr. John Keller from the Met Department is giving a webinar on SPAC, which stands for Center for Security Printing and Anti-Counterfeiting Technology. And that is June 17th at 11 a.m. Mountain Time. So 2 weeks and Thursday. So I'll drop that information in there too. But it looks like Travis answered all their questions. So that doesn't happen often, but we appreciate it. It's a beautiful building. I haven't been over there yet, but I'm sure it's a very beautiful building. And you still have the marble floors?
Still have the marble floors, marble stairs, and a lot of white walls right now that are just waiting to be filled with some good stuff.
Do you want to put your email in the chat to the attendees
Sure.
in case they have any questions or anything that they could email you about? We appreciate it.
So I included my email address and also the office phone. So whatever version would be easiest to go and contact me if you've got questions, you've got advice for what it is that we should be doing, or if you want to get involved. I'd be happy to go and help out. And thank you for listening to me.
Yes. Well, thank you. Yep. And if you guys have any questions that you think of afterwards, we'll wrap up this call. You can just feel free to email Dr. Kowalski and or me, and we'd be happy to get them. So have a great day. Enjoy the nice weather. It's warm and hot here. So everyone's curious about what's going on in Rapid City. Hot and almost high 80s, 90-degree weather. So
Yeah, we're supposed to hit 90s this weekend, aren't we?
mm-hmm.
So
Yeah, so beautiful.
Summer's finally here.
Yes, that it is. So, well, I appreciate you all. So thank you.
Thank you.